This is section 5.4, Factor and Solve Polynomial Equations. In this section, you will learn how to factor and solve other polynomial equations. So far, when we have been looking at quadratic expressions, we have had the general trinomial, which is in the form of, when you factor it, you just have the two sets of parentheses, and they work out nicely. We have a perfect square trinomial. When you factor the two, it's just going to be the same thing squared. We have a difference of two squares. That's when you start with a binomial, but when you factor it, you end up with two factors. And then we have a common monomial factor, which means there's something that you can factor out of both pieces. If you notice, we can factor out an x from both of these pieces, and 4 goes into both of them, so we can factor out a 4x and then just write down what is left. A factorable polynomial with integer coefficients is factored completely if it is written as a product of unfactorable polynomials with integer coefficients. So this means there's nothing else you can factor, there's nothing else you can factor out, then it is completely factored. So we need to factor the polynomial completely. Now, if you notice, each of these pieces have an x. So the first thing we can do is we can factor an x out of each piece. Now, if I factor an x out of x cubed, we are left with x squared. If we factor an x out of 2x squared, we're just left with 2x. And if we factor an x out of the next piece, we are only left with 15. Now, the part that's inside the parentheses is something we know how to factor. Remember, we can put the negative 15 on top, so we're looking what multiplies to get negative 15, that adds to get a positive 2. We have 1 and 15, or we have 3 and 5. Now, because it multiplies to get a negative number, we do know one side will be negative, and since when you add, they end up positive, we know it's going to be the smaller numbers that are negative. So negative 3 plus 5 does give us 2. So we can factor this as x minus 3 and x plus 5. Now, if you look at all those pieces, none of them have anything else that can be factored out, so we are done with that problem. We need to factor this polynomial completely. First, let's factor out anything that they have in common. So 2 goes into both pieces, so I can factor out a 2. And we have x's. We can factor out x to the third from each of these. So if I factor out a 2, 2 divided by 2 is 1, x to the fifth. If I factor out an x to the third, subtract those exponents, it's going to leave me with x squared. If I have negative 18 divided by 2, it leaves me with 9, and we factored out the x cubed, so we're just left with x squared minus 9. Now, this is in the form of a difference of two squares. I can take the square root of both of those. It is subtraction, so we can factor that piece again. Remember, if I can take the square root of this, and I can take the square root of this piece, and if this is subtraction, we can factor. So the square root of x squared is x, square root of 9 is 3, and we will have one positive and one negative. If you notice, there's nothing else can be factored out, so we are done with this problem. So again, let's start by factoring out anything that there's in common. So I have an x squared, I can take an x squared out of here, and I can take an x squared out of here. And 4 goes into all of these pieces. So I can factor out a 4x squared. 4 divided by 4 is 1. X to the fourth, if I factor out an x squared, it's going to leave me with x squared. Minus 16 divided by 4 is 4. X cubed, factor out an x squared, you're left with x. And 16 divided by 4 is 4. We factored out the x squared, so we are done here. Now, if we factor this piece, you are looking to see what multiplies to give us a positive 4 that adds to give us a negative 4. So I have 1 and 4, or I have 2 and 2. Since we multiply to get a positive, it means the signs are the same. When we add, we get a negative, so that does mean all the signs are negative. And if we're looking to see what adds to get a negative 4, it would be a negative 2 and a negative 2. So we can actually write this as x minus 2 squared, because it is the same term twice. Now, there are some special factoring patterns. If we have a cubed plus b cubed. So you can take the cube root of the first piece and you can take the cube root of the second piece, and they are added together. Then you're going to end up with a plus b times a squared minus ab plus b squared. And if it's a difference of two cubes, so a cubed minus b cubed, then it would be a minus b times a squared plus ab plus b squared. So if we take a look at this, we only have two terms. I can take the cube root of the first one, and the cube root of x cubed tells me that a is equal to x. The cube root of 64 tells me that b is equal to 4. Since we can take the cube root of both of those, then this is a sum of two cubes. It is a sum because it is a plus. So it tells us if we have a cubed plus b cubed, we can factor this as a plus b times a squared minus ab plus b squared. And we already found that a is equal to x, b is equal to 4. So we have x squared minus x times 4 plus 4 squared. And if we simplify this, this is going to give us x squared minus 4x plus 16. Now we do need to check at this point to make sure we can't factor this trinomial, but there is nothing that multiplies to give us a positive 16 that adds to get a negative 4, so we are done factoring at this point. If we factor this one, first we need to see if we can take the cube root. I cannot take the cube root of 16, and I cannot take the cube root of 125, but I can take the cube root of an 8, and to turn the 16 into an 8, we would have to factor out a 2 first. Also, we cannot take cube root of x squared, but I can factor an x squared out of both of these. So if we factor out a 2x squared, this will leave us with 8x cubed minus 2 goes into 250, 125 times. Now we need to see if we can take the cube root. So if we try to take, if a cubed is equal to 8x cubed and b cubed is equal to 125, if we take the cube root of both sides, this is going to tell us that a is equal to 2x and b is equal to 5. Now, because this is a difference problem, we are going to make this a difference one, which tells us that it's going to be a minus b times a squared plus ab plus b squared. But don't forget, we still have this 2x squared out front, so we cannot lose that part. So if we plug in our a and our b, a minus b times a squared plus a times b plus b squared. And if we simplify, 2x squared, 2 squared gives us 4x squared, plus 2 times 5 gives us 10x, plus 5 squared, which is 25. We can also factor by grouping. So if we have 4 terms together, and we can rearrange them so that the first 2 have something in common that we can factor out, the second 2 have something in common that we can factor out, and then if what's remaining in the parentheses are the same, then we will just take the stuff that's in front of the parentheses, put them into one group, and then the stuff inside the parentheses will remain together. This will only work if you can end up with the same thing inside each parentheses when you are done. So if we take a look at this one, we're going to group here and another group here. So what can I factor out of this first group? Both of those pieces have at least an x squared, so we can factor that out of each of the groups. And if we factor out an x squared, we're going to be left with x minus 3. And the next group, negative 16 goes into both of them. Negative 16x divided by negative 16 leaves me with x, and 48 divided by negative 16 leaves me with a negative 3. Remember, your goal is to end up with what's inside the parentheses to be the same for both of them. So this will give us x squared minus 16 times x minus 3. Now, if you notice with that first term, that x squared minus 6, that is a difference of two squares, so we can factor this piece again. Because I can take the square root of x squared, I can take the square root of 16, and it is subtraction, so we can continue to factor. So the square root of x squared is x, the square root of 16 is 4, and you will have one of each sign. All right, for this one we just need to factor completely. If you notice, we can take the square root of this piece, and we can take the square root of this piece. So the square root of 16x to the fourth, square root of 16 is 4, square root of x to the fourth is x squared. This is going to be one of each sign, and the square root of 81 is 9. Now this factor on the left is done because it is a positive, and we can't do anything else with that. But the one on the right, I can take the square root of 4x squared. I can take the square root of 9, and it is subtraction, so we can factor that one some more. So this will be 4x squared plus 9. And if we factor this one again, the square root of 4x squared is going to give us 2x and 2x. The square root of 9 is 3. And we will have one of each sign. On this one, we're going to see, is there anything that they have in common first before we try to start to factor? So all of them do have p's, so we can factor out a p squared. And all of them are divisible by 2, so we can factor out a 2 before we start. So 2p to the 8th, if we factor out a 2p squared, will just leave us with p to the 6th, plus 10 divided by 2 is 5, p to the 5th, and p to the 2nd, we factor out the 2nd. Remember, we're going to subtract this exponents, gives me p to the 3rd. And 12p divided by 2 gives me 6, but we already factored out the p squared, so we are done there. Now, we need to factor this part. We are seeing what multiplies to give us 6, that adds to give us 5. We do want to see what multiplies to give us p to the 6th, and that's going to be p cubed and p cubed, because remember, when we add the exponents, we end up with p to the 6th. You also know it's going to be p cubed because that's what's in the middle. Now, multiplies to get 6, adds to give us 5. It could be 1 and 6, or it could be 2 and 3. Since it is multiplied to get a positive number, you know the signs are the same, and because when they add to get a positive number, they are both going to be positive, and we're going to be left with p squared plus 2 and p squared plus 3. Now, because this is a p cubed plus 2 and a p cubed plus 3, it is possible that we could have to continue factoring if it was one of the special factoring patterns of either a sum of 2 cubes or a difference of 2 cubes. So you have to see, can you take the cube root of those pieces? I can take the cube root of p cubed, but I cannot take the cube root of 2, and I cannot take the cube root of 3, so we are done in this case. But if instead it would have been p cubed plus 8, you can take the cube root of 8, so we would have had to continue factoring that problem. What are the real number solutions of the equation that is given? So when we're looking for real number solutions, that means you need to find all of your x's. So to start, we are going to take everything to one side. So right now, to move this 18x cubed, we are going to subtract it from both sides. And this is going to give us 3x to the 5th minus 18x cubed plus 15x is equal to 0. Now we're going to see, is there anything that we can factor out? All of the pieces have x's, so I can factor out an x. And all of the pieces are divisible by 3, so we can factor out a 3. So this is going to leave us with x to the 4th minus 6x squared plus 5 is equal to 0. Now we need to factor that next part. Multiplies this to give us x to the 4th would be x squared and x squared. We want to see what multiplies to get a positive 5, adds to get a negative 6. So I have 1 and 5. Multiplies to give us a positive, means the signs are the same. Adds to give us a negative, means both signs are negative. So we're going to have x minus 1 and x minus 5. Now, we have to see if we can factor either of those again. Because this is subtraction, both of them could work that way, but you would have to be able to take the square root of both pieces. I can take the square root of x squared. I can take the square root of 1 and still get a whole number, so I can factor that piece again. On the other piece, I cannot take the square root of 5, so that one cannot be factored any farther. But the square root of x squared, we have x and x. Square root of 1 is 1, and remember we have 1 positive and 1 negative. Now it does tell us to find the solutions. That means we need to take each of these pieces and we need to set each of them equal to 0 and solve. So we have 3x is equal to 0. We have x plus 1 is equal to 0. X minus 1 is equal to 0. And x squared minus 5 is equal to 0. For the first one, to solve it, we would just need to divide both sides by 3, and we would get x is equal to 0, because 0 divided by 3 is just 0. On the next one, we would subtract 1 from both sides, because right now we're adding it. So we have x is equal to negative 1. On the next one, we have x minus 1, so you will add 1 to both sides, and this will give us x is equal to a positive 1. On the last one, we're going to add 5 to both sides. So we have x squared is equal to 5. To get the x by itself, we do need to take the square root. But remember, when you take the square root, you do need positive and negative. So x is equal to plus or minus radical 5.